So last lesson we were looking at classifying quadrilaterals, and that each different type of quadrilateral has slightly different features. And the reason why we go through that is to look at when we're solving these angle rules, what things we can use to help us in answering the questions. So just to start off with, I've got a quick starter here. I've got some shapes on the left hand side, I've got their names mixed up in the middle, and then I've got some features on the right hand side. On some paper, all I want you to do is match up the shape with the name with the type. So if you could pause the video, get that done, and then we'll discuss the answer. Okay, thanks for giving that a go. So let's take a look at the answers. Okay, so obviously a square, all the sides are equal. This one's a rhombus. You can see that the little notations on there meaning that all the sides are the same length, and you've got the parallel line symbol. So hopefully you've picked up the fact that if there's two lines, it matches any other side that's two lines in length. There's two arrows, it matches up any side parallel with any other side. The other thing is we can see that the angles we can match up as well with this rhombus. It's saying that this angle and this angle are the same length. So the next one is a parallelogram, which is a rectangle with two parallel sides that aren't 90 degrees. So two pairs of angles are the same. This one's a rectangle. All the angles are equal, so in other words, 90 degrees. Our kite, okay, the opposite pair of angles are the same. And the last one is our arrowhead, where a pair of angles are equal. So they're the key ones. There's obviously lots of different variations. There's not a trapezium there that we talked about yesterday. So this isn't an exhaustive list. So the big question is, and the big rule is, that angles in a quadrilateral always add up to 360 degrees. So this is exactly the same as the triangle where we were looking at 180 degrees. So how does it help us? Well, obviously we can solve questions. Those add up to 360. Now, if for instance this was an unknown like x, then suddenly I can use that feature to work out what the size of x is, because it should add up to 360. Just like this question here, they should add up to 360. Is that if I take the other three, they add up to 327. So what's left over is that is 33 degrees. Our arrowhead here, we've got three of the four angles. Be really careful about this question. I'm not entirely sure why, but boys always struggle and they think that it includes this angle on the inside, because we're so used to having acute or obtuse angles. This reflex angle is the internal angle of the quadrilateral. And what we can see is that that adds up to 222, which is, again, from the previous questions we've done, isn't a normal sized angle. So again, this one, on its appearance, it looked like an impossible question where we've only been given two angles here. But if we think about this being divided across the middle, what have we created? Well, we've created two isosceles triangles. So this angle, so I'll call it something else, we'll call it A and A. Those angles must be the same if it's an isosceles triangle. And if we flip over there, then this angle and this angle must be the same. Well, hang on, if x is equal to a and a plus b on one side, and this angle here is also a plus b, then those angles must be equal. So we can use that feature, obviously, if the two angles we've got are 82, take that away from 360, it means that both these angles here must add up to 278, which we can divide by 2 to give us 139. So you can see using the features of the quadrilateral help us to answer questions. So here's an exercise. Hopefully the blue one is pretty straightforward, and then the other two slightly more difficult. The yellow one's using more than one rule that we've covered already, and the final one's using a little bit of algebra, which you may or may not be comfortable with. Give all three a go. So pause the video, give all three a go, and then we'll have a chat about the answers. Okay, so hopefully you gave that a go. So here are the answers. So the key thing here is that's 360 take away 131, 133, and 29 gives us 67. So that's nice and straightforward. This one here, we were just given this angle on the internal here. So we need to use some of the rules that we've used previously. 50 degrees is vertically opposite, so we should have been able to get that one. 129 is supplementary, and that means then if we have three angles here, we can work out the fourth one. So 360 take away 128, 50, and 129, and then that gives us our answer. Now the last one is basically just, you've got your four corners, they're in terms of x, so add them together and we end up with 32 plus 8, 32x plus 8. You can solve that to work out that 1x is equal to 11, so then we can go 4 times 11, take away 6 to give us 38. 11 times 11 plus 10 gives us 131, and so on. Don't worry about that one so much. That's just really an extension question for those boys who wanted to give it a go. But really well done if you managed to get 53 degrees there. So there's a exercise in on the lesson page from the OneNote. You need to go back there and complete that.